In this video, we're going to look at how we can solve quadratic equations when we've got algebraic fractions involved in the equations. Now, often when we have algebraic fractions involved in equations, we will get a quadratic that we need to solve. So let's look at a couple of examples. The first one, x plus 5 over 4 equals 9 minus x over x. Now the way to solve this equation is to multiply both sides by x to get rid of the x on the bottom of this fraction, and to multiply both sides by 4 to get rid of the 4 on this side. So when we do that, we get x times x plus 5 on this side equals 4 times 9 minus x on this side. The reason for that is when we multiply the right hand side by the x, it cancels with the x on the bottom. And when we multiply the left hand side by the 4, it cancels with the 4 on the bottom. So we've cross multiplied to get this. Now we need to expand, and we get x squared plus 5x equals 36 minus 4x. Now we've got a quadratic, and to solve a quadratic we need it to be equal to 0, so we have to do a bit of rearranging. So x squared, well, we've got plus 5x and we've got minus 4x over here, so we're going to add that 4x on, so we get add 9x, and we've got a 36 over here, so we're going to take that away, so minus 36, and now our whole equation is equal to 0. Once a quadratic is equal to 0, we factorize. So the beginning of each bracket is going to be x, because we just have an x squared. They multiply to make 36 and have a difference of 9. Well, that's going to be 12 and 3. We need plus 9x, so the 12 needs to be positive and the 3 needs to be negative, which gives us our answers of x equals 3 and x equals minus 12. We can check these by substituting them into the original equation. 3 plus 5 over 4 is equal to 8 over 4 is equal to 2, and 9 minus 3 over 3 is equal to 6 over 3 is equal to 2. So they indeed work. Similarly, if we were to use minus 12, we would also find that they worked. But x equals 3 and x equals minus 12 are our solutions to the equation. In this example, we have 4 over x minus 1 over x plus 1 equals minus 1. This one's slightly different, as x is on the denominator of two different fractions, and we have a single number that has no fraction that's a part of it. So there's several ways we could approach this. We're going to do it by combining the two algebraic fractions by the subtraction. So first of all, we need a common denominator, and the common denominator is going to be x plus 1, and then on the top of the first one we get 4, and we have to multiply the bottom by x plus 1, so we have to multiply the top by x plus 1. And in the second one we get 1, and we have to multiply the bottom by x, so it's 1x. And that's all equal to minus 1. We haven't done anything to the equation, we're simply rewriting the left hand side. Now we can rewrite that as 4x plus 4 minus x over x brackets x plus 1, and that's still equal to minus 1. Now we're going to multiply by the denominator to remove the fraction. So we get, well, 4x minus x is 3x plus 4 is equal to minus x plus 1, because when we multiply minus 1 by the denominator, we get minus 1 times x plus 1. Now we need to expand. So we've still got 3x plus 4 on this side, minus x squared minus x. And now we want the quadratic to be equal to 0, so we need to get all of the terms on one side. So we're going to add the x squared, so we get x squared. We've got a 3x, and we need to add that x on so that we've got all the x's on one side, so plus 4x. And finally we've got the plus 4 on that side, and now it's equal to 0. Now we've got a quadratic equal to 0, we can factorize it. X in the beginning of both brackets, that's going to be 2 and 2 to give us 4 and 4. So our answer is x equals 2, and that is the only solution to this equation. So if we have algebraic fractions, we either need to combine them by using a common denominator and then remove the common denominator, or we could cross multiply in this one because they were equal to each other.